Today we are looking at lesson 3.5 on page 215. We are dividing multi-digit numbers, and our learning target today is that we will be able to fluently divide multi-digit numbers using this standard algorithm. And we will actually start by building on what you learned in 5th grade with using remainders. So we'll eventually move away from using remainders, but for today we will still be working with remainders. And we in 6th grade we will be using the standard algorithm. So you might have learned some excellent strategies in elementary school like partial quotients. And partial quotients is still a really useful tool for helping us to get an estimate as to where we need to be. But we'll be moving forward with dividing decimals and eventually dividing fractions, and partial quotients won't really help us with those types of divisions. So we want to make sure that we are very strong in this standard algorithm for dividing. So again, today we're working in chapter 3, lesson 5, page 215. So first of all, we want to make sure we have a common vocabulary that we will be working with. When one number is divided by another, the result is called a quotient. Okay, so the answer to a division problem is called a quotient. The dividend is the number that is divided. And the divisor is the number that is used to divide another number. Okay, so in this division problem below, okay, we have 240 divided by 80 equals 3. 240 is our dividend, 80 is the divisor, the number that's that we are dividing by, and 3 is the quotient, the answer to the division problem. So we're looking at a health link today. We're looking at our cross-content standards here. When you are at rest, it takes about 60 seconds for a single blood cell to travel around your body and make it back to your heart. In 120 seconds, about how many times does it take a single drop of blood to travel around your body and back to your heart? Write the dividend, divisor, and quotient in the diagram below. So if we have 120 seconds and it takes 60 seconds for it to go through once, how many times will it go through your body in 120 seconds? So the 120, we want to know how many times 60 will go into that 120. Okay, so we know 6 times 2 is 12, so 60 times 2 would give us a 120. 60 times 2, 120. Okay, when we have Camila here. Camila's target heart rate should be about 200 beats per minute. Estimate the number of times Camila's heart will beat in 1 second if her heart is working at this rate. So 200 beats per minute. And if the rate is 60 seconds for a single blood cell to go through her body, okay, that'll be, we want to estimate because this, I think they asked for, yes, estimate. So 60 goes into a 200 about how many times? Well, I know 6 times 3 is 180, or 6 times 3 is 18. So 60 times 3 would be 180. So approximately about 3, okay? 3 beats in 1 second. Okay, all right, and let's do some examples with dividing 3-digit numbers on the next page. So now we're on page 216. In this lesson, you will divide multi-digit numbers. Use estimation to help you place the first digit in the quotient. Okay, so estimation is a really useful strategy because it helps us to get first of all, close and make sure our answer is reasonable. And second of all, it helps us to get each number that we will need in our problem as we divide it out. So if I have the problem 351 divided by 9, it's really difficult to get to that level of exact level of specificity or precision in our problem. But we do know that 9 times 4 would give us 36. So 9 times 40 would give us about 360, so about 4. So, but we rounded that up, so that's going to be a little bit too big. So we could round it down to 3 and see how that works out. And they actually did this problem for us. So in the exact answer, we have 351 divided by 9. Okay, so 9 times 4 would be too big because that would give us 36, so we can do 9 times 3. 3 times 9 gives us 27. 35 minus 27 is 8. And then we bring down the 1, and 9 goes into 81 9 times. 9 times 9 is 81, and subtract, we get 0. So 351 divided by 9 is 39. Our original estimate was 40, so that's extremely close. Okay, so our answer is a reasonable answer. Example 2, we have 31 being divided into 878, or 878 divided by 31. So we wanted to estimate these. We think of compatible numbers. So 31 and 878. 31 would be, so think how many times can that go into a number that's close to 878. So if I rounded this 878 to 900, and I rounded this 31 down to 30, then I can see that 30 would go into 900 about 30 times, because 3 times 3 is 9. 30 times 30 would give us 900. So our estimate would be somewhere close to 30. So our answer should be right around 30. And then when we go ahead and divide that out precisely using the standard algorithm, we get 28 remainder 10, which is close to 30. Okay, so let's do a few examples. At the bottom of page 216, we have 768 divided by 8. So here, I'm just going to work over at the top of the page in the work zone. 768 divided by 8. Okay, so when I look at these two numbers, I know I think of 8 times 9, and I think that's 72. Okay, 8 times 9 would give me 72, so 8 times 10 would give me 80. That would be too big for these first two digits. Okay, so I want to put a 9 here. So when I look at this written problem here, does 8 go into 7? No, it's too big. So I have to go to the next digit. That's why I was looking at the 76. Does 8 go into 76? Yes. How many times? 9. Okay, because 10 was too big, 8 was too small. So 9 times 8 is 72. And then we subtract. 76 minus 72 is 4. Bring down the 8. And 8 goes into 48 6 times. 6 times 8 is 48. Subtract, we get 0. So our answer is exactly 96. We didn't have any remainders in this problem. Okay, we always box our answer. Okay, and if we look at Got It B, down at the bottom of the page, we have 318 divided by 16. 318 divided by 16. Okay, so 16, does it go into 3? No, so I can't write anything above the 3. Does it go into 31? It will go into 31. So if I think of 16, it will definitely go in once. 16 times 1 is 16. If I doubled the 16, that'd be 32. That's a little bit too big, so it's not going to be 2. It'll have to just be 1. And then 16 times 1, 1 times 16 is 16. And when I subtract, I get 15. 31 minus 16 is 15. And then I bring down this 8. Okay, so then I want to see how many times 16 goes into 158. Well, 158 is really close to 160. 16, 1, 6, goes into 160 10 times. So it's not 160, so it can't be a 10, but it'll be close. It'll be a 9. So let's try the 9. 9 times 6 is 54. Write the 4. Carry the 5. 9 times 1 is 9. Plus the 5 we carried is 14. Okay, so then we subtract. We get 4 and 1. So we have a remainder of 14. 14 is less than our divisor, 16, so that's an acceptable remainder. So our answer is 19, remainder 14. And we always box our answer. And that was pretty close to our estimate of 20. So let's go on to dividing with 4-digit numbers on page 217. The steps for dividing 3-digit dividends and 4-digit dividends are the same. And then I just want to remind you, when you see these tutorial icons, you can look at the online tutorial lessons using your digital textbook. Okay, example 3, we have 6,493 divided by 75. So if we wanted to get round numbers here, we could say 6,493 is quite close to 6,400. 6,400, I can round that 75 up to 80. Okay, 6,400 divided by 80 would be 80. Okay, just like 64 divided by 8 would be 8. So add the zeros there, that would be 80. So our answer should be pretty close to 80. So that is our estimate for reasonableness. And then when we divide, this is all worked out for us. So 64 divided by 75. So first of all, does 75, can it go into 6? No, it's too large. Can it go into 64? No, that's too large. So we can't put anything above the 6, and we can't put anything above the 4. Okay, so does 75 go into 649? Yes, 8 times. 8 times 75 is 600, and then we subtract 649 minus 600 is 490, excuse me, is 49, and then we bring down the 3, and then next, how many times does 75 go into 493? 6. We do 6 times 75, we get 450, subtract, we have 43, so it's a remainder of 43. And so 86 remainder 43 is relatively close to our answer of 80. So that's a pretty reasonable answer. 86 remainder 43. Number 4. The average person has 1,460 dreams per year. What is the average number of dreams a person has each night? So if you have 1,460 dreams per year and you want to know how many you have per night, there are 365 days in a year. Okay, so 365 nights in a year. So 1,460 divided by 365. So this is actually already done for us here, but our estimate 1,600, 400. So we rounded that way up. 400 goes into 1,600 4 times. So we try that out. 4 times 5 gives us 20. Write the 0. Carry the 2. 4 times 6 is 24, plus the 2 that we carried is 26. Write the 6, carry the 2. 4 times 3 is 12, plus the 2 we carried is 14, so 1,460. So the average person would have 4 dreams per night. Okay, so then we have some example problems to work out here. Letter C, we have 4,321 divided by 56. Okay, so we don't really have a lot of room right here. Let's work over on the side at the top. Okay, so that was 4,321. This is example C. Okay, divided by 56. So I look at 56. Can it go into 4? No, it's too big. Can 56 go into 43? No, that's too big. Can it go into 432? Yes. Okay, so if I take the 60 or the 56, 400, I'm going to estimate around 7 there. So let's see if that will work for us. 7. Okay, 7 times 6 is 42. And then, so how I estimated that 7, I should pause right there. So I kind of rounded this down to, so 400, I rounded it down. This is, I rounded that down to 50. 50 would go into 408 times, but this is 432, so, and it's 56, not 50, so I'm going to try a 7. It might be an 8, but I think it's going to be closer to 7, so we'll try the 7 first. And if it's wrong, we write it in pencil and math. I'm using an erasable pen, so we can always fix it. All right, so 6 times 7 is 42. Write the 2, carry the 4. 7 times 5 is 30. 35 plus the 4 we carried is 39. So we're good there. So then we subtract 2 minus 2 is 0. 43 minus 39 is 4. So that is good. That's less than 56. So the number that we subtract, if you remember from elementary school, has to be less than the number that you're dividing by. Otherwise, you underestimated, and you would need to make that number a little bit bigger. And just to avoid confusion, I'm going to erase that 4 that we carried. And then here, we bring down our 1, so we have 401. So this is 392, really close to 401. So I'm going to do another 7 right here. 7 times 56, we just did that, is 392. Okay, so then we will subtract. I'm going to count up here, so 401 minus 392. So I'll count up. 392 to 400 is 8. So to 401 would be 9. So we would have remainder 9. Okay. So 5 times 8 would give us 40. 50 times, so we would have an 8 here. This is pretty close to 77, remainder 9 would be pretty close to 80. Okay, so 50 times 80 would be 4,000. So that's pretty close to 4,321. So it's a reasonable answer. Let's look at a couple more examples. Let's look at letter D. 8,465 divided by 91. 8,465 divided by 91. Okay, so okay, so 91 cannot go into 8. It can't go into 84. It can go into 846. I know 9 times 9 is 81. So 9 times 90 would be 810. So that's going to be pretty close. We'll estimate a 9 here. 9 times 1 is 9. 9 times 9 is 81. And then we subtract. We get 27, and then we bring down our 5. And 27 is less than 91, so that's good. Needs to be less than the divisor. Then 275. So how many times does 91 go into 275? Well, 9 times 3 is 27. So we'll do a 3. 3 times 1 is 3. 3 times 9 is 27. 275 minus 273 is 2. So we have 93, remainder 2. All right. And then we have one more example at the very bottom of this page. Let's see if I can get that on the screen. Yes. To promote its opening weekend, a water park gave the local middle school 1,050 free tickets. The middle school has 350 students. Each student will receive the same number of tickets. How many tickets will each student receive? So 1,050 tickets divided among 350 students. So 1,050 divided by 350. And there's some workspace for us right there. Okay, so can 350 go into 1? No, so I can't write anything above the 1. Can 350 go into 10? No, so I can't write anything above the 0. Does 350 go into 105? No, so I can't write anything above the 5. And some teachers might have taught you to put X's above that. That's fine if you like doing that method. Can it go into 1,050? Yes. Okay, so if I rounded that down to 300 and rounded this down to 900, 300 would go into 900 3 times. So I'm going to start off with a 3. And I think that's going to get us really close. So 3 times 0 is 0. 3 times 5 is 15. Write the 5, carry the 1. 3 times 3 is 9, plus the 1 we carried is 10. So that was actually perfect. If we had a remainder larger than 350 here, we would need to bump that up to 4. But we're good here with our 3. So each student will receive 3 tickets. So 3 tickets per student. Okay, so 3 tickets per student. Let's do a few more examples with the division because it is such an important skill and we want to really be having several opportunities to practice our fluency. So let's look at the top of the page. Example 5 was done for us. So let's go to the guided practice so we can do these problems for ourselves. So number 1, we have 736 divided by 8. Okay, so does 8 go into 7? No. And I'm going to zoom in on that problem just a little bit more. So does 8 go into 7? No. Okay, 8's bigger than 7. Can 8 go into 73? Yes. Well, I know 8 times 9 is 72, so I will be able to put a 9 here. Okay. You can rewrite this if you want a little bit more space. If you're not a really small writer, or if you are a really big writer, you can write on lined paper. Okay, just make sure you're showing your work, boxing your answers. Every problem needs to have a number. Okay, so when we go in order with our numbers, 1, then 2, then 3. Okay, so again, we're back here. 9 times 8 is 72. Subtract 1, or 3 minus 2 gives us 1. Bring down the 6. 8 goes into 16 2 times. Okay, 2 times 8 is 16. We have 0 there, and we have nothing else to bring down, so we're finished. This was exactly 92. Number 2, we have 620 divided by 11. Can 11 go into 6? No, so I can't write anything about the 6. Can it go into 62? Yes. Well, 11 times 6 is 66. That's too big, so we need to round it down to 5. 5 times 11 is 55, or you can do 5 times 1 and 5 times 1. Okay, 62 minus 55 is 7. Bring down the 0. 11 goes into 70 6 times because 11 times 6 is 66. So 11 times 6, 66. That gives us 4. And we'll talk about what to do when we start getting more precise answers and we're not using remainders anymore. But for now, we just want to refresh your memory about long division from elementary school. And for now, we're just going to stick with remainder 4. Okay, but not for long. That's going away soon. So 56, remainder 4. Okay, example 3. So I'm going to round this just to get a reasonable answer, check for reasonableness. This is about 20. If I round that up to 8,000, 20 times what will give us 8,000? About 400. Okay, so our answer should be close to 400. Okay, so let's go ahead and see. 19. Does 19 go into 7? No. Does 19 go into 78? Yes. Okay. So if I estimated that as 20, 20, 40, 60, 80, that's going to be about 4 times. So let's try that. 4 times 9 is 36. Write the 6. Carry the 3. 4 times 1 is 4, plus the 3 we carried is 7. So that's perfect. 78 minus 76 is 2. Bring down the 1. 19 goes into 21 one time. And I'm going to write that 4 a little bit smaller, just so I have room. Okay, and so 21, how many times does 19 go into 21? It goes in 1 time. 1 times 19 is 19. And then I subtract. 21 minus 19 is 2. Okay, and then I brought down this one, so now I need to bring down this 4. So I have 24. 19 goes into 24 1 time. So again, I brought down the 4, so I make sure I'm writing this 1 above the 4. Because that's the number that the last number I was dividing by. 1 times 19 is 19. 24 minus 19 is 5, so we have a remainder 5. So 411 remainder 5, and we box our answer. That was close to our estimate of 400. Okay. 37, and we're dividing it into 3,511. So if I rounded that to 35 and this to 3,500, that's going to go in about 100 times. Okay. Again, if I rounded this to 35 and rounded this to 3,500, how many times does 35 go into 3,500? About 100 times. Okay, so our answer should be close to 100 for number 4. Okay, so we're just going to check that estimation helps us to make sure we're reasonable with our answers. So 37, does 37 go into 3? No, so I can't write anything above the 3. Some teachers teach you to put an X there. That's excellent. Does 37 go into 35? Nope, super close though. Okay, so I know this number is going to be larger, like a 9 probably. Does 37 go into 351? Yes. Okay, so I know 37 times 10 would give us 370. Okay, that's just a little bit too big. So I'm going to go ahead and put a 9 there. And that's above that 1. Okay. 9 times 7 is 63. Write the 3, carry the 6. Okay, 9 times 3 is 27. Plus the 6 we carried is 33. And then we subtract. I'm going to count up, so that's going to be 18. So I count up 33, 43, 53 would be 20, but it's not 53, it's 33, so down 2 would get 18. Okay, or you can regroup and borrow. I just counted up. And then I'm going to bring down the 1. So 37 into 181. I'm going to try a 4. Yeah, that's good. Okay, then I'm going to erase this 6 because I'm regrouping again. So a lot of arithmetic here. I would probably write this on line paper if I had this to do it over again, just so we're not so crowded. Okay, so 4 times 7 is 28. Write the 8, carry the 2. 4 times 3 is 12, plus the 2 we carried is 14. Okay, so we need to do some regrouping here. I can't do 1 minus 8, so I'm going to go over to the 8 and borrow. The 8 becomes a 7. This is 11. 11 minus 8 is 3. 7 minus 4 is 3. So we have remainder 33, and 33 is less than 73, so that is good. So 94, remainder 33. Okay, and let's do a word problem. Zach bought 2 new jet skis for $15,480. And when we have word problems, when we see numbers, we want to consider how they consider into the equation. It doesn't say they were $15,480 each or per jet ski. It says 2 for $15,480. So he got both of those jet skis for the $15,480. He will make 36 equal payments. How much will each payment be? So it's just the $15,480 divided by 36. Okay, the 2 does actually not come into play here. It just tells us how many items he bought with his $15,480. So it's a long division problem. And let's see if we can fit this right here. 15, I'm going to leave a little, I always like to leave a little blank space because remember, we're going to have our answer above the dividend there. So 15,480 is our dividend. That's being divided by 36. Okay, so does 36 go into 1? No. Does it go into 15? No. Does it go into 154? Yes. So I think of 30, so I'll go count by 30s. 30, 60, 90, 120. So I'm going to try 4 there. 4 times 6 is 24. Write the 4, carry the 2. 4 times 3 is 12, plus the 2 we carried is 14. So we have 154 minus 144, that's 10. And then we bring down this 8. Okay, so I'm going to round this 36 up to, well, 30. I'm going to estimate 3 times. 30, 60, 90. So we'll try a 3 there. We may need to readjust. And I'm going to erase the 2 that we carried from before, so it doesn't get confused with this one. 3 times 6 is 18. Write the 8, carry the 1. 3 times 3 is 9, plus the 1 we carried is 10. So that was actually perfect. 108 minus 108 is 0. We bring this 0 down. How many times is 36 going to 0? 0. So we have 430. So Zach's payments will be $430 each. And I just rewrote that so it's a little bit more neat than right there. So then we want to make sure that that is a reasonable answer. So let's actually do a quick check there. So 430, let's just round that to 400. And 36, let's round that to 40. Just to check for reasonableness. 4 times 0 is 0, 4 times 0 is 0, 4 times 4 is 16, and then this 0, because we weren't just multiplying by 4, we were multiplying by 40, so that's 16,000. That's very close to 15,840, so it is a reasonable answer. That's our check for reasonableness, so we can always check that at the end as well. How is estimation helpful? Well, that's what we just did right here. Actually, we used that estimation to make sure our answer was reasonable, so we know if we're in the right ballpark. So it can help you to determine whether your answer is reasonable, if it makes sense or not. So if my answer were $43 per payment, that wouldn't get us close to the $16,000. Okay, so it can help you to determine whether your answer is reasonable. Okay, and that is just a refresher of the long division that we started learning in elementary school. Again, right now we're still keeping remainders when we're doing our problems, so remainders are okay for now, but pretty soon we'll be learning some different methods so that we can give our answer in a little bit more precise terms instead of using remainders. Thank you.